Hey everybody, today we are going to continue our unit on triangles by talking about congruent triangles. So we'll talk a little bit about congruent figures of any kind, but then we'll zero in on triangles. So congruent figures are two figures in which all pairs of corresponding parts are congruent. Okay, so that means all sets of corresponding sides and all sets of corresponding angles will be congruent. So we're going to write a congruent statement for these triangles and identify all pairs of congruent corresponding parts. Now, I think it's actually going to be easiest if we start with the angles, okay, because we have marks here that tell us what angles are congruent. So angle A, that's the right angle here, is congruent to angle F. Angle B with one arc would be congruent to angle G, and angle C with two arcs is congruent to angle H. Now that's actually going to make it pretty easy to write a congruence statement. So for the congruence statement, I will say triangle ABC is congruent to triangle. Now when we write a congruence statement, it should be in corresponding order. So if angles A and F are congruent, then since I have A first, I need F first over here. And then B is congruent to G. B is second, so G is second. And then C and H are congruent. C is third, so H is third. It really doesn't matter what order I write the first set of letters, but once I set that order, I need to make sure that these go in corresponding order. So if B is first, then G would be first over here. If C is first over here, H would be first over here. Okay, now corresponding sides. And I can actually get that from this congruent statement. AB, those are my first two letters, is congruent to segment FG. My second set of letters, BC, would go with segment GH. And then CA, that's the last and the first, so HF. Okay, so those are my congruent sides. And I can compare that to the tick marks. AB has 2 tick marks. FG has 2 tick marks. BC has 3 tick marks. GH has 3 tick marks. CA has 1. HF has 1. Okay, so in this diagram, QRST is congruent to WXYZ. Find the values of X and Y. So I have an X right here on angle W. Okay, and according to this right here, angle W must be congruent to angle Q. So 5x plus 5 is equal to angle Q, which is 65. So I can subtract 5 from both sides and get 5x equals 60, and divide by 5 and get x is 12. So there is my value of x. Okay, then to find the value of y, I can put a 12 right here, so this is really y minus 12, and I've got side xw. Okay, so that's the first 2 letters here, so RQ would be corresponding. So this side equals 6, so y minus 12 is equal to 6. And I can add 12 to both sides and get y equals 18. Okay, so now we are going to identify all pairs of congruent corresponding parts in these two figures given that FGHJ is congruent to STUV. Now, this congruent statement is written in corresponding order, so I can really write all the congruent angles without even looking at these figures. I know that angle F is congruent to angle S. And then my second letter, angle G, is congruent to angle T. And angle H is congruent to angle U. Angle J is congruent to angle V. I can do the same for all four sides. I have segment FG congruent to segment ST. Then I can slide over to the next two letters, GH. Segment GH is congruent to segment TU. HJ. Segment HJ is congruent to segment UV. Okay, and then I can go JF. Segment JF is congruent to segment VS. Okay, so here are my four congruent sets of angles and my four congruent sets of sides. Now, find the value of X and the measure of angle G. So X here is actually on angle G. And according to this up here, angle G and angle T are corresponding. So that means G and T are the same. So G is 103, which actually gives me this answer right here. The measure of angle G is 103 degrees. To get X, I can set 2x minus 7 equal to 103. So I can add 7 and get 2x equals 110 and divide by 2 and get x is 55. The third angles theorem. Third angles theorem says that if two angles of one triangle are congruent to two angles of another triangle, two angles of one triangle are congruent to two angles of another triangle, then the third angles are also congruent. So here I have A is congruent to D, B is congruent to E. Now if I take these two away from 180, I'm going to get some measure here for C. Okay, and I can do that because triangles are 180. If I take these two away from 180, well, they're the same as these other two. So I'm going to get the same thing for F as I did for C. So I know that angle C is congruent to angle F. Okay? So if I've got two sets of congruent angles, then I know the third set is also congruent. Okay? The reflexive property of congruence. This is one that's going to come up a lot in our coming lessons. Any geometric figure is congruent to itself. And a way that manifests itself a lot is like right here. These two triangles are sharing a side. So I've got a triangle over here and a triangle over here, and they are sharing a side. And it is a true statement that segment MK is congruent to segment MK. It sounds simple, and we all know it's definitely true, but it's also actually pretty important to know that we can always state that a side of a triangle is congruent to itself, especially important when two triangles share a side. It can actually happen that two triangles share an angle also, and we could use that same property, like angle H is congruent to angle H. All right, so congruent figures have all sets of corresponding sides and all sets of corresponding angles congruent. So we want to determine if there's enough information to say that these triangles are congruent. If they are, then we're going to write a congruence statement. Okay, so I need, in a set of triangles, 3 sets of congruent sides and 3 sets of congruent angles. I have a set of congruent sides here, and I have a set of congruent sides here, but I need a third set of congruent sides. And look at this, they share a side, and that reflexive property says I can use that to say that segment HG is congruent to segment HG. So I actually have 3 sets of congruent sides. I have a set of congruent angles here and another set here, and that third angles theorem tells us that if I've got 2 sets of congruent angles, I actually have a third also. So it turns out that all 3 sets of sides and all 3 sets of angles are congruent. So yes, there is enough information to say that these triangles are congruent. So write a congruence statement. So I'm going to call this triangle over here FGH. Triangle FGH. There's no magic to that order. It could be FHG or GHF, whatever order I want. But I've set my order as triangle FGH. And that is congruent to triangle. Now that I've set this order matters. So F is congruent to J, so I need to put J first over here. Then I have G, and this side of vertex G is congruent to this side, so I'll call the other side G. And then H, I've got an angle H for this triangle and an angle H for this triangle. So yes, they are congruent, and that is my congruence statement. Here we are given that point E is the midpoint of segment AC. Okay, so that means that from A to E is the same length as from C to E, because E is right in the middle. E is also the midpoint of segment BD. So that means from B to E is the same length as from D to E, because E is right in the middle of segment BD. And I already had one tick mark here, so I've actually got all three sets of sides congruent. Okay, now can I say that all three sets of angles are also congruent? Well, I have a pair of vertical angles right here, so I know those are congruent. I also have these arrows here, which tells me these lines are parallel. And that's important because between parallel lines, alternate interior angles are congruent. So on this transversal right here, I've got a pair of alternate interior angles right there. They are congruent to each other. And on this transversal, I have a set of alternate interior angles right there. They are congruent to each other. So I have all three sets of sides and all three sets of angles congruent. So yes, these two triangles are congruent. So I'll start with this triangle over here. Triangle, and I'm going to call it ABE. Okay, now that I've set that order, I have to follow that order over here. So angle A is congruent to angle C. So I'll start this side with angle C. Then I had B and D are congruent, so I'll go with B next. And then the vertical angles E and E. So yes, they are congruent, and here is my my congruence statement. How about this set of triangles? Is there enough information to show that they are congruent? So I have one set of congruent sides, I have another set of congruent sides, and they share a side. So the reflexive property says this side is congruent to itself, so I have three sets of congruent sides. I have congruent angles here, and the third angles theorem tells me if I've got two sets of congruent angles, then I actually have three sets of congruent angles, so that third set of angles is congruent. So I can see now three sets of congruent sides and three sets of congruent angles, so yes, the triangles are congruent, so I need a congruence statement. So triangle, and I'll call this one ADC, is congruent to triangle. Okay, now on this triangle, this angle A has one arc. That matches with this over here, one arc, so that's a C first. Okay, then D is congruent to B. And then in this triangle over here, this angle C has two arcs, so does this angle A, so I'll finish with A. In this picture, what is the measure of angle D? Well, angle D is congruent to angle A, so if I can find A, then I'll know the measure of angle D. And I have a pair of vertical angles here. So this right here is 47 degrees. And we know that in a triangle, there's 180 total degrees on the interior angles. So 180 minus 71 minus 47 is 62. So the measure of angle A is 62 degrees. And since A and D are congruent angles, the measure of angle D is also 62 degrees. Okay? So I've got 62 here. So I've got a 47, 62, and 71, and this triangle is 47, 62, and that means this is also 71. So is there enough information to show that these two triangles are congruent? So I've got three sets of congruent angles. A pair of 47s, a pair of 62s, a pair of 71s. All three sets of angles are congruent. What about all three sets of sides? I do not know if E is the midpoint of BC. So I cannot say that BE and CE are the same. And I don't have any reason to know that AB and DC are the same. So I'm going to have to say, no, there's not enough information to say they are congruent. So I cannot write a congruence statement.